Autonomous agents are now performing real-world actions, like reading emails, querying databases, and executing code in a rapid chain reaction of steps. When systems take sensitive actions without permission, such as deleting a production database or emailing a client, even a small error can cause significant damage before a developer can intervene. To manage this risk, we use a human-in-the-loop workflow. The agent handles the complex reasoning and planning, but waits for a human to confirm any action that meets a specific sensitivity threshold. Today, we are building an event-driven workflow that implements this safeguard. We will program an agent to pause just before a critical operation, preserve its current progress, and resume execution only after receiving a manual approval. Trading a small amount of speed for deliberate oversight provides a predictable safety barrier. This ensures that an autonomous process only completes sensitive tasks when it has been explicitly authorized. Implementing a pause and resume feature requires a shift from traditional linear Python scripts toward an event-driven architecture. In this model, individual steps in the workflow don't call each other directly. Instead, a step performs its task and emits an event, which subsequent steps then receive and process. Frameworks like Lemma Index provide pre-built classes for this interaction. The input required event signals that the workflow needs external data, and the human response event carries the decision back into the system. We configure our sensitive tool to utilize these events. Instead of executing its main code immediately, the tool halts and broadcasts an input required event to the broader workflow. Once the event is broadcast, the tool remains suspended. It is programmed to sit in a waiting state until it specifically detects a corresponding human response event in the stream. This modular structure changes the agent from an opaque process into an observable system, where each step is a discrete, manageable event. With the tool ready to pause, we focus on the main execution loop that monitors the agent's live progress. By adding a conditional check to our execution loop, we can program the application to listen for that specific input required signal. When the listener identifies a pause event, the application immediately stops its iteration, preventing any further autonomous steps from triggering. To prevent the agent from attempting to skip this step, we use a strict prompt that requires the LLM to use our custom interruption tool for any task involving external databases or client communications. Technically, the application has yielded control back to the user without exiting. All the current memory, variables, and context are held in a frozen state in the background. Intercepting the stream at this layer allows you to hold the agent's context in a stable state for as long as the human reviewer needs to make an informed decision. While the application is paused, we surface the agent's proposed action to the user through the interface. The human reviewer can approve the action, reject the entire workflow, or edit specific parameters to correct the agent's plan. Once a decision is made, that human input is packaged into a human response event and injected back into the suspended workflow. This event travels back into the main pipeline, carrying the user's specific instructions or approval directly to the waiting tool. The suspended tool recognizes the incoming response, extracts the instructions, and finally executes the command with the human-verified parameters. This injection of specific feedback allows a human to guide the agent through a sensitive task without re-executing the entire workflow from the beginning. To verify the system, we will run our workflow script and monitor the output in this terminal on the right. As the script begins, the agent autonomously analyzes the prompt, identifies the necessary tools, and begins building its execution plan. When the agent reaches the sensitive database tool, the terminal output halts. The input required event has successfully triggered a system-wide pause. The terminal now displays the agent's proposed database query. We will type approve and hit enter to provide the manual authorization. The workflow immediately catches our response, resumes the tool's execution, and prints a final message confirming the task is complete. This event-based logic establishes a baseline for managing human review, ensuring that automated processes remain subject to specific approvals within a production workflow.
Enhance your coding skills with us. Don't forget to subscribe to Code 5 Food for the latest updates and tutorials.